Hi everyone, I'm Hasib. I am a graduating PhD candidate at Concordia University in Montreal, Canada. So today I'll be presenting our work RSUD20K, a dataset for road scene understanding in autonomous driving. In this work, we aim to understand road scenes in new geographic locations with application in autonomous driving. Existing object detectors tailored for learning on datasets like cityscapes and Kitty cannot generalize to new unseen objects. For example, in this image taken from Bangladesh, if we feed it to an object detector trained on the cityscapes dataset, these objects might go unmissed or get misclassified because they do not have any prior knowledge on what these objects are. One workaround is to leverage the OpenSet or zero-shot capabilities of large vision models, but they also fail in terms of predicting new unseen objects. We performed a data-centric experiment where we had the labels created using large vision models and compared against the manual annotation. Models trained using labels generated by large vision models are much worse off. Even DETIC fails, which is an object detector trained to predict up to 20,000 classes. We introduce RSUD20K dataset, which consists of a total of around 20,000 high-resolution images with 130,000 bounding box annotations of 13 different objects. Our scalable data engine used to create RSUD20K increases accuracy and efficiency. It also reduces cost in comparison to manual human annotation. For the first stage in our data engine, we collected videos recorded using an in-car dashcam. Then, prior to manual annotation, we identified 13 different classes which were common in driving scenarios from day-to-day driving. The annotation time for this stage was 48 seconds per image. In the semi-automatic annotation, we trained a YOLO V6 on manually annotated data. After that, we generated and manually refined pseudo-labels on validation and test sets. In this process, the annotation time reduced to 8 seconds per image. In the fully automatic annotation stage, we trained a YOLO V6 again on the manually annotated data and used it to pseudo-label the unlabeled images. We filtered out images with null predictions, resulting in a total of around 20,000 images with bounding box labels of 13 different objects. RSUD has data imbalance similar to real-world cases. Here we show two plots which basically answer how many images in each dataset split belong to a particular class and how many bounding box instances exist for each class. We identified that the classes person, rickshaw, and private car are overrepresented, whereas pickup truck and human hauler are underrepresented. The highest instances are of person with over 30,000 bounding boxes, and the lowest is for human hauler, which has only 455 instances. RSUD consists of objects with different viewpoints, scenes like crowded areas, outskirts, nighttime, rain, and glare. For objects in different viewpoints, this addresses the challenge posed by narrow and laneless roads where we need to identify objects that are coming towards us or from the side but in the same direction. There are also fine-grained classes like rickshaw and rickshaw van in RSUD20K. It also consists of different weather conditions like daylight, nighttime, and rainy. There are also scenes from crowded areas and outskirts of cities, and also captures the illumination challenges, for example, glare from the sun. On the right, we show a histogram which shows the number of images by the number of bounding boxes. And we find that most images have around 4 to 9 objects. RSUD is really challenging. Scenes with no typical lane markings and narrow streets. This is uncommon in existing datasets for scene understanding in autonomous driving. Vehicles like rickshaw and rickshaw van are human-powered, posing recognition difficulties as models may easily misclassify them as persons. Most images depict crowded street scenes with densely cluttered objects, leading to heavy occlusions. Certain scenes were captured in both daylight and nighttime, including rainy conditions, introducing challenges related to varying illumination. RSUD is the only publicly available largest dataset for road scene understanding in Bangladesh. We compared it with previous datasets like Dhaka AI, Poribohon BD, and MVI-Net. In terms of the number of images, we found that RSUD has the highest number of images compared to the other ones. We also found that the other datasets mostly focused on traffic detection and vehicle classification used for surveillance applications. But RSUD20K is for autonomous driving. We also benchmarked state-of-the-art object detectors on RSUD and found that YOLO models were the best. Some classes had lower mean average precision as they have subordinate categories and need more fine-grained recognition. YOLO models are good in cases of occlusions and viewpoint differences, as well as various weather conditions. Here we show some visualizations for the outputs predicted by the different YOLO models. We also found that model scaling results in better performance. On the left, we can see a table which basically shows that whenever we scale an object detection model, it tends to produce better results in terms of predictive accuracy on RSUD20K. On the right, we show two plots showing that pseudo-labeled data from the fully automatic annotation stage helps detection across various object detectors. This is true for both the validation and test sets. Consider using RSUD in your research. RSUD is a dataset for autonomous driving with 20,000 high-resolution images and 130,000 bounding box annotations across 13 different objects. RSUD captures diverse viewpoints, crowded environments, and various weather conditions, presenting real-world scenarios still unsolved by state-of-the-art object detectors. The dataset can be easily accessed using the following link. Thank you for listening. Bye.